All righty. So let's take a look at question 25, which is a good synthesis problem. It says, how could we take this compound, which is 2-butyne, and then we want to make a meso compound. So we want to make this compound where you have the methyl groups coming out like this. We have the hydrogens in the back like this, and then we have a hydroxyl here and another hydroxyl. And again, you can clearly see that this is a meso compound. So let's look at the possibilities here. So the first one is that we start with hydrogen and deactivated palladium. Okay, deactivated palladium is the same thing as saying Lindlar's catalyst, which is again a type of deactivated palladium. So deactivated palladium. So again, it's the same thing as Lindlar's catalyst. So that's going to give us cis-2-butene, and then it says to treat that with osmium tetroxide, a catalytic amount, and then it says H2O2. That's the same thing as using NMO. It's like using NMO. It's just a co-oxidant. So that's going to give us syn addition of the alcohol, and so that's going to give us this here, where we have both of the alcohols added to the same face of the molecule. So I'm going to draw it the same way it is, that I have it up top. So this is going to work. That's going to give us the right compound. If we look at the second way, we start with our 2-butyne again, and we're going to treat that with sodium in liquid ammonia. That's going to give us trans 2-butene. And then if we treat that with the same conditions, so maybe I'll just do a copy paste here. So I'll just copy this and I'll paste it down here. There we go. That again gives us a syn addition. So that would give us this compound. So like this, where we have one hydroxyl coming up like this and the other one coming up like this. But if we rotate this carbon-carbon bond, then we end up with this, where we have one hydroxyl coming up and the other hydroxyl coming down like this. So that would actually give us a racemic mixture, right? We'd end up with a mixture of enantiomers, and so that is not going to work. So we'll put an X by this one. We'll put a red X here. So there we go. So far, only number one. Let's try number three. So with number three, we start with our 1-butyne. We do our deactivated palladium. So I'm going to just copy and paste this because it's the same. So we'll copy this guy and we'll paste it down here. So we end up with cis-2-butene. So we'll throw that in here. And then what we're going to do is we're going to treat it with a peroxy acid. So first step is peroxyacetic acid. I'll just write RCO3H. And then we're going to treat it with water and sodium hydroxide, which is just a way to pop open an epoxide. It's like as if we used H3O+, but you just use basic conditions to do it. So that'll work to just open the ring. Okay, so there we go, sodium hydroxide and water. And that's going to give us the anti-addition. So we'll have one hydroxyl coming up and one hydroxyl going down like that. And so in that case, you'd end up with an enantiomer as well. So that is not going to work. And then in the last case, number 4, again, we're starting with our 1-butyne and we're treating it with sodium and liquid ammonia. So I'm going to just copy and paste this. There we go. So there's our first step. And then in the last step, we're going to treat it with the same conditions we did up here. So I'll copy and paste this again. And again, this is just a trans addition or anti addition of the diol. And so now we're going to end up with this compound. Let me grab my pen here. So you're going to have one hydroxyl pointing up and one hydroxyl pointing down. But this is a meso compound because if you rotate this carbon-carbon bond, you end up with this where you have the one hydroxyl pointing up and the other hydroxyl pointing up. So this is a meso compound. And so the answer is number 1 and 4. So 1 and 4, 1 and 4. There we go. And so that means the answer is C would be the correct answer. All right, there we go. So this works. So number 1 works and number 4 works. So I wanted to cover a little more detail on this with you, okay? Anti-addition to a trans, and if you rotate it, you do end up with a meso. Let's try it again, Warren. Let's take a look here. So I made some notes of different things I wanted to look at. So let's review, okay? And we'll talk using more, we'll be a little more consistent with the conditions that are in our book, okay? So if we have a cis alkene, come on you, I have a cis alkene, like cis-2-butene, and if I treat this with osmium tetroxide, a catalytic amount, and NMO is my co-oxidant, I end up with this case, adding the hydroxyls on the same face of the molecule, right, like this. So I end up with a meso compound, right? However, if I take trans 2-butene and I treat it with a peroxy acid like MCPBA, followed by acid, right, that gives me anti-addition. And so I have one hydroxyl pointing up and the other hydroxyl pointing down like this. But right when I rotate this bond, I see that I actually do end up with a meso compound where one hydroxyl is going to be up and the other hydroxyl is going to be up. Okay, so like one of the students just summarized, if you have the anti-addition to a trans alkene and you rotate it, you end up with a meso. Now, conversely, if you were to start with cis-2-butene, okay, and you treat that with a peroxy acid, followed by hydronium in the second step, that's going to give you anti-addition. So one hydroxyl is pointing up, the other hydroxyl is pointing down. That's going to give you a racemic mixture. Okay, that gives you a racemic mixture. Now, what if you took the trans, okay, if you took the trans 2-butene, come on, trans 2-butene, and you treated that with osmium tetroxide, a catalytic amount, and NMO is your co-oxidant, that's N-methylmorpholine N oxide, then you end up with this compound where you have the hydroxyls on the same face of the molecule, which, again, you don't want to be fooled into thinking that's a meso compound because there's no plane of symmetry here. And when you rotate this bond, what you see is that you actually end up with this compound, which we saw in the last example, and you end up with the enantiomer as well. Okay, so if you think about bromination, right, we could apply the same rationale to bromination. If you have cis-2-butene and you treat that with bromine, you can pick a solvent like carbon tetrachloride, or you could put no solvent. In that case, you would end up with a racemic mixture because the bromination occurs with anti-addition. However, if you were to use a transalkene and treat that with bromine, okay, and carbon tet or nothing, whatever, doesn't matter, okay. Oops, I can make that a little prettier. There you go. You would end up with one bromine up and the other bromine down like this. But again, if you rotate this bond, you see that that is actually a meso compound where you have one bromine coming up like this and the other bromine coming up like that. Give me a thumbs up if you're like, you know what, that makes more sense now after looking through all these different examples. I like the way you put it. Yeah, you know what? You're not alone. Everybody likes to jump to conclusions. Everybody likes to go for the low-hanging fruit. I'd be the first person to do it, okay? So I'm the first guy to always try to go for the easiest way out. And sometimes it, sometimes it involves some bond rotation or something. So there you go, my friends. And that kind of covers syn and anti-addition, and it's something that shows up even more in organic chemistry too. So that is, something that you definitely want to be on the spot with is, syn and anti-addition. All right, there we go. But as far as our exam is concerned, I don't have any conditions in there, I don't think, that you won't recognize immediately from something that comes, we're written the same way as it is in our book. So don't stress about, oh, am I going to see something not phrased the same way as it is in the book? It's all phrased the same way as it is in the book. And if you've looked around the internet at all or looked at any other organic chemistry textbooks, you'll see that you'll see a variation in the way things are presented between textbooks. Right.